Okay, class, picking up where we left off at, we ended up with the approximation of 322.02, and we took the square root of both sides, and that left us plus or minus approximation of 17.94 is equal to t minus 57. So now we were supposed to add 57 to both sides, which we show here because we're trying to get t by itself, and we will have 57 plus or minus 17.94 equals t. Now, what we would end up doing is we would add 57 to the 17.94, which gives us 74.94, and then also we would take 57 minus the 17.94, which would give us 39.06. Now remember, all of the dates are since 1900, so this means that in 1939 and 1974, the poverty threshold would be $3,000. And that is the final answer to that problem. Now it says, what is the vertex of the model? What does it mean in this situation? Hint, notice the equation is in vertex form. So let's take a look at the vertex form. We got f of t is equal to a times t minus h plus k. Now our vertex is h, k. So h will represent our x and k represents our y for our vertex. Okay, so now we look back at the original equation that we had here and go back up here to the top. So now we have p of t. Okay, this is the equation we had here. Now if we look at this equation, this 57 is our h and 1406 is our k. So it'd be 57 comma 1406. And this would be our vertex. So we could put that here, which is 57 1406. Now it says, what does this mean in this situation? It basically means this here. First of all, we know based upon this model that this is 1957. So in 1957, the poverty threshold is $1,406. And that's what this means in this situation. And also, this will also be the minimum point as well, this vertex. It says here, square roots of negative numbers. When we try to take the square root of a negative number, it is impossible to find a real number that works. For example, the square root of negative 25. We know the square root of 25 is 5 or negative 5, but we would not be able to get a negative 25. So in order to make sense of the square root of a negative number, we introduce a new type of number, the imaginary numbers. The square root of negative 1 is equal to I, where I is called the imaginary unit. Imaginary numbers were first discussed. Well, we can read this at our leisure. Let's go down here to the problems. It says simplify the following by hand. The square root of negative 49. We know that the square root of 49, since this is not an equation, it would be 7. But because of this negative sign, it'll make it 7i. Now we come here. Let's concentrate on the radical first. The square root of negative 81, we know the square root of 81 is 9. But because it's negative, it will be I. And since we have this negative on the outside, it will be a negative 9i. Now we come here. We have the negative square root of a negative 3 over 20. So first of all, let's just do the square root of 3 over 20. So that would be square root of 3 over square root of 20, which would be the square root of 3 over the square root of 4 times the square root of 5, because we take out the perfect square. So this will be the square root of 3 over 2 square root of 5, and we know we cannot leave this square root in our denominator. So we multiply the numerator and denominator by the square root of 5. And that will give us the square root of 15 all over. We know the square root of 5 times square root of 5 will be 5 times 2 is 10. Now that took care of this here. But remember, it was a negative under the square root, so it'll be I. And since this negative was on the outside, it'll be negative as well. And this is the final answer. Now we do the same thing here. We just go and we take the square root of 2 over the square root of 54. Now we know the highest perfect square in 54 is 9. So it'll be square root of 9 times the square root of 6, which will give us the square root of 2 over 3 square root 6. And we will multiply the numerator and denominator by the square root of 6. So this will give us the square root of 12 all over. We know the square root of 6 times square root of 6 is 6 times 3 is 18. But here's the problem. The square root of 12 can be broken down to the square root of 4 times the square root of 3. That'll be all over 18. So this would be 2 square root 3 over 18. Now 2 and 18 both has 2 in common. 2 goes into 2 once, 2 goes into 18 9 times. So our answer here would be the square root of 3 over 9. But remember, we had a negative under the radical, so it would be square root of 3 over 9i. And that would be the final answer. Now it says imaginary numbers. Numbers of the form bi, and complex numbers are numbers of the form a plus bi. Now it says simplify the following by hand. Write the results in complex form, a plus bi if necessary. Now we have 3 plus or minus the square root of 9 over 21. We know this would be 3 plus or minus 3 all over 21. Now we would do 3 plus 3 over 21, and we also would do 3 minus 3 over 21. So that would be 6 over 21, and this would be 0 over 21. We could divide both of these by 3, and that would be 2 sevens, and 0 divided by 21 is 0. So that is our final answer. Now, we're basically taking this problem here and doing the same thing, but this would be 3 plus or minus 3i all over 24. Now, what we could do is this here, because we know we cannot combine 3 and 3i. We can factor out a 3, and that will leave us 1 plus or minus I all over 24. And 3 and 24 both have 3 in common. 3 goes into 3 once. 3 goes into 24 8 times. So it would be 1 plus or minus I over 8. And that would be your final answer for that problem. Now we come here and we do the same thing. Now I'm not going to do all of the problems. I'm going to do probably about 2 more, and then we're going to move on to some other problems. So I'm going to do D here. Now if we look here at D, this would be negative 4 plus or minus. Now we have a negative 160. Now first of all, we know that we're going to have an I come out of here. But the 160 can be broken down to square root 16 times the square root of 10. And this would be all over 2. So it would be negative 4 plus or minus I. The square root of 16 is 4. So it would be times 4 square root of 10 all over 2. So this would be negative 4 plus or minus 4i square root 10 all over 2. Now we know all of these values can be divided by 2. So this would be negative 2 plus or minus 2i square root 10, and we won't have a denominator. And that will be the final answer. Now, we're going to do, let me do E here. Now with E, we will have negative 8 plus or minus. Now the square root of 1200. Now we could do this as the square root of 400 times the square root of 3 all over 40. So this would be negative 8 plus or minus, this would be 20 square root 3 all over 40. Now if we look at 8, 20, and 40, all of them has 4 in common. So it would be negative 2 plus or minus 5 square root 3 all over 10. And this would be our final answer. But you know what, now that I think about it, we can simplify this even more. We would just have to separate this. So we had negative 2 over 10 plus or minus 5 root 3 over 10. Now negative 2 over 10 will give us a negative 1/5 plus or minus this 5 and 10. We know that can simplify to 1/2. So that would be square root of 3 over 2. And this would be the final answer. Now, they said solve the following using the square root method. Now we scroll down here. Now using the square root method, we know we would take the square root of both sides here. And this will give us x is equal to plus or minus. Remember, this is a negative 25, so it would be 5i. So it would be x equals plus or minus 5i. Here we would do the same thing. Take the square root of both sides. This would be t plus 5 is equal to plus or minus 8i. So we will subtract 5 on both sides. And t is equal to negative 5 plus or minus 8i. Now we would take the square root of both sides here as well. And this will give us 2a plus 4 is equal to 2i plus or minus 2i. Now we will subtract 4 on both sides. We add 2a equals negative 4 plus or minus 2i. And divide each side by 2. So we have a is equal to, now we see that all of these values are divided by 2, so it would be negative 2 plus or minus I. And that would be the end of that problem. Now we take this problem here, take the square root of both sides. We add x plus 3 is equal to plus or minus. Now we could take out our I, but we would have to change 32 to the square root of 16 times the square root of 2 to pull out the highest perfect square. So we add x plus 3 is equal to plus or minus. Now square root of 16 is 4 times I is 4i square root of 2. Now we will subtract 3 on both sides. And x equals negative 3 plus or minus 4i square root 2. And we're done. And that is it.